Hi everyone, my name is Kamaros Eliyati. I'm a final year student majoring in medical physics of University Science Malaysia. In my video today, I will talk about detecting defects in material using ultrasound. So, when we heard the word ultrasound, what the first thing crossed our mind? I believe most of us think of the well-known application of ultrasound that used in hospital purposely to generate the image of the baby in the womb during pregnancy. However, in my video today, I will not discuss further on the application. I will discuss on another application of ultrasound, which is detecting defects in material. So, let's get started. First and foremost, what is ultrasound? Ultrasound is sound wave with frequencies higher than upper audible limit of human hearing, as it has frequencies greater than 20 kHz. In the line range shown, you can see the frequency of ultrasound wave and other sound wave with suitable applications. Detecting defects in material using ultrasound, or also known as ultrasonic testing, actually is one of the non-destructive testing methods, or can easily be simplified as NDT method. So, what does it mean by NDT? NDT is a testing and analysis technique used by industry to evaluate the property of a material, component, structure, or system for characteristic difference or welding defects and discontinuities without causing damage to the original part. In other words, when the inspection or test is completed, the part can still be used. This is one of the major advantages of NDT method. Other than ultrasonic testing, there are more NDT methods such as visual inspection, radiographic testing, magnetic particle testing, and liquid penetrant testing. Then, what is ultrasonic testing? Ultrasonic testing is an NDT method that uses short, high-frequency ultrasound wave to identify flaws or defects in material. They generally work by emitting waves into material. The waves then are reflected. By measuring this wave, the properties of the material and internal flaws can be identified. Typically, the ultrasonic testing inspection system consists of three major components, which are an ultrasonic transducer, pulsar, and display unit. A pulsar is an electronic device that can produce high-voltage electrical pulses to the transducer. When driven by the pulsar, the transducer generates high-frequency ultrasonic sound energy into the material in the form of sound wave. When there are discontinuities or defects such as occlusions, porosity, and cracks in the sound part of the mechanical energy will be reflected from the discontinuities or reflector surface. The reflected sound wave signal received by the transducer is then transformed back into an electrical signal, and its intensity is shown on the display unit. The sound wave travel time can be directly related to the distance that the signal has traveled. From the signal, information about reflector location, size, orientation, and other features can be determined. The first type and application of ultrasonic testing is Advanced Ultrasonic Backscatter Technique (AUBT). AUBT is an ultrasonic testing technique developed for detecting damage from high temperature hydrogen attack (HTHA). The technique is for use in pressure vessels and piping. The technique makes use of high frequency broadband ultrasonic testing probes and a digital oscilloscope. This allows it to provide both an A-scan display and frequency analysis. Secondly is long-range ultrasonic testing, or LRUT. LRUT is an ultrasonic testing method developed to allow for testing large volume of material from a single test point. This method works by fixing transducer rings uniformly around a pipe. These rings then generate a series of low-frequency guided waves. The wave can then propagate symmetrically along the pipe axis. This provides complete coverage of the pipe wall. Next, internal rotating inspection system, IRIS or IRIS. An IRIS is an ultrasonic technique used to detect corrosion in piping and tubing. Using an internally inserted probe that generates sound wave, the system works by inserting a probe into a flooded pipe. The probe then moves through the pipe, scanning as it goes. Last but not least, time of flight diffraction, TOFD. TOFD is a method used to look for flaws in wells. It uses the time of flight of an ultrasonic pulse to find the location of a reflector. To find the time of flight, the method uses a pair of ultrasonic transducers. The transmitter emits low-frequency waves that propagate at an angle. They only diffract back to the receiver if they hit a defect. In general, ultrasonic testing has several advantages and disadvantages. It's useful because it can scan for flaws performed on all types of material, both on and underneath the surface. It is also useful for its incredible accuracy and reproducibility in flaws detection. On the other hand, it also has the advantages that it requires a good deal of skill and training to perform, as it is capable of portable or highly automated operation. As conclusion, ultrasound is capable in detecting defects in material. This proves that ultrasound is not solely applicable for hospital purpose, but it's also very useful in industry field. That's end my video for today. Thank you for watching.